Good day everyone! Welcome back to my YouTube channel. It's me again, your teacher Marlene Nuno, and I'm going to discuss all about the trigonometric ratios of special angles. One of the special triangles that we have discussed measures 45, 45, 90 degrees. So in the figure, it is a 45, 45, 90 triangle. So the legs are congruent. It is represented as A. And the length of the hypotenuse is the leg times the square root of 2. Therefore, we have A square root of 2 in the figure. Now let us find the 6 trigonometric functions. So let us start with sine 45 degrees, which describe as opposite over the hypotenuse. So opposite the 45 degrees is A over the hypotenuse, which is A square root of 2. Then to simplify, we need to rationalize by multiplying this to A square root of 2 over the square root of 2. Now, we can cancel A over A because its value is 1. Then 1 times the square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4, or simply 2. So sine 45 degrees has the value of square root of 2 over 2. Similarly, for cosine 45 degrees, which describe as adjacent over the hypotenuse, so adjacent to 45 degrees is A, and the hypotenuse is A square root of 2. So similar to the first one, we have to rationalize this and we will arrive at the same answer. So cosine 45 degrees has the measure of square root of 2 over 2. Now for the tangent 45 degrees, which describe as opposite over the adjacent, so of course we will arrive at A over A. So the value of tangent 45 degrees is 1. For its reciprocal, let us have the cosecant 45 degrees. So we have the value, the hypotenuse is A square root of 2 over the opposite, which is A. So we can cancel A over A, which is 1, then times the square root of 2. Therefore, cosecant 45 degrees is square root of 2. For secant 45 degrees, we have hypotenuse A square root of 2 over the adjacent A. So again, we can cancel A over A so that secant 45 degrees is also square root of 2. And for cotangent 45 degrees, which is also A over A. So they are equal to 1. Another special right triangle is a 30, 60, 90 degree triangle. So in the figure, opposite the 30 degrees is A, which is our shorter leg. And then its adjacent is A square root of 3, and the longest, which is the hypotenuse, is 2A. So for the value of sine 30 degrees, which is the opposite over the hypotenuse, we have A over 2A. And then we can cancel A over A. So the value of sine 30 degrees is 1/2. For cosine 30 degrees, which is adjacent over the hypotenuse, so the adjacent A square root of 3 over the hypotenuse 2A. So similarly, we can cancel A over A. So cosine 30 degrees has the value of square root of 3 over 2. For tangent 30 degrees, which is opposite over adjacent, we have A over A square root of 3. So at this point, we need to rationalize by multiplying these two, square root of 3 over the square root of 3. So we can cancel A over A, which is equivalent to 1. So we will arrive at square root of 3 over 3. For the reciprocal, Let us have first cotangent 30 degrees, which is the reciprocal of tangent 30 degrees. So we will arrive at a square root of 3 over a. So we can simplify this by cancelling a over a, which is equivalent to 1. So cotangent 30 degrees is equivalent to square root of 3. Next is secant 30 degrees. So this is the reciprocal of cosine 30 degrees. So we will arrive at 2a over a square root of 3. So we need to cancel a over a and rationalize. So multiply to square root of 3 over square root of 3. And then we will arrive now at 2 square root of 3 over 3. This is the value for secant 30 degrees. And of course, the reciprocal of sine 30 degrees is the cosecant 30 degrees. So we have 2a over a, cancel a over a, therefore we will arrive at 2. Let us have now the 60 degrees. So this time, the opposite of 60 degrees is a square root of 3. So let us start with sine 60 degrees, which is opposite over the hypotenuse. So we have a square root of 3 over 2a. So simply cancel a over a. So the sine 60 degrees has the value of square root of 3 over 2. For cosine 60 degrees, we have adjacent is a over the hypotenuse 2a. So cancel a over a. So cosine 60 degrees is 1/2. How about tangent 60 degrees? So we have the opposite over the adjacent. So a times square root of 3 over a. Cancel a over a. So we will arrive at square root of 3. For the reciprocal, we have the cotangent 60 degrees. So we will arrive at a over a square root of 3. So we have to rationalize this. Multiply to square root of 3 over square root of 3. And then cancel natin si a over a. So we have square root of 3 over 3 for the value of cotangent 60 degrees. For secant 60 degrees, so looking now at the cosine 60, take its reciprocal, we will arrive at 2a over a. So cancel a over a, so that's secant 60 degrees is 2. And the last one, we have the cosecant 60 degrees. So take a look at sine 60. This time, we have to take its reciprocal. So we have 2a over a square root of 3. So rationalize and cancel a over a. So the value of cosecant 60 degrees is 2 square root of 3 over 3. Now let us see the application of these values. So try to evaluate the following. For the first example, let's say we have sine 60 degrees plus tangent 60 degrees minus cosine 30 degrees. So looking back at the values that we obtained, the value of sine 60 degrees is square root of 3 over 2. Then the value of tangent 60 degrees is square root of 3. Then cosine 30 degrees is square root of 3 over 2. So try to check these values if correct. Now to simplify, try to look at the first term, square root of 3 over 2 is similar to the last term, square root of 3 over 2. So subtracting this, we will get 0. So the value of the function is square root of 3. have another example. Let us evaluate secant square 45 degrees minus cosecant squared 45 degrees plus cosecant 30 degrees. So the value of secant 45 degrees is square root of 2. Then we have to square it. Minus the value of cosecant 45 degrees, which is the same as square root of 2. Again, we have to take its square. And the value of cosecant 30 degrees is 2. So the square of the square root of 2 is simply 2. The same with the middle term, then added the last term. So 2 minus 2 is 0 plus 2. So we will arrive at 2 as the simplest form. Now let me give you another example. Let us evaluate our example number 3, which is tangent square 30 degrees added to sine squared 60 degrees plus tangent 45 degrees. So getting the value of tangent 30 degrees will give us square root of 3 over 3. Then we have to square it since it is indicated in our given. Then the value of sine 60 degrees is square root of 3 over 2. Again, we have to square it. And the value of tangent 45 degrees is 1. So getting the square of our first term, we will get 3 over 9. So this is simplified into 1/3. Then added to the square of the square root of 3, which is 3, and the square of 2 is 4. And let us copy the last term. So looking now at the denominators, we will arrive at 3, 4, and 1. So our LCD is 12. So 12 divided by 3 is 4 times 1. Then the middle term, 12 divided by 4 is 3 times 3. And then 12 times 1 for the last term. So we have, this is simplified to 4 plus 9 plus 12. So 4 plus 9 is 13 plus 12 is 25. So this is 25 over 12 is our final answer. Well, that's all for my discussion. Now it's time for me to check how well do you know. So based on our discussions, comparing the trigonometric ratios of 30 degrees and 60 degrees, which of them are equal? That's all for this lesson. Thank you for watching. I hope you learn a lot from this. Thank you for watching. God bless everyone.